Thank you very much for that introduction, and thanks to the Institute on the Environment for inviting me to give this presentation. It's a real pleasure. So first, one comment on the title of this talk, this black hat, white hat thing. And this title was stimulated by several years ago when I was working in Silicon Valley. I was invited to spend 3 days on a fishing trip with the senior CEOs and executives from the independent petroleum producers, sort of the small scale, smaller petroleum guys that we don't really hear about. And my goal was to give them lectures on biotechnology and biofuels and the green economy during the course of the fishing junket, so in the evenings and in the mornings. And first time I got up there, I was introduced as the black hat. And I guess it's a matter of perspective, and so that stuck into my mind that I have been a black hat because I was the guy talking about renewables. I want to have one slide on my current firm. Just you heard a little bit about it, but we are First Green Partners, an early stage investment company. Name comes from one of my favorite poems by Robert Frost. So we've been around since 2011 and do early stage investments in what we call the carbon value chain. Roughly half of our investments in technologies related to renewable carbon, but we also realize that fossil carbon is not going to go away anytime soon, and so we also do early stage investments in fossil carbon, and we focus on investments throughout North America, although we are based here in the Twin Cities. So this slide illustrates the crux of the talk. And the point here, and you might not be able to see the axes, but it's dollars per million BTUs on the y-axis and time on the x-axis, and here starting from 1990 going to the present. Historically, the price of petroleum and the price of natural gas have pretty much tracked right on top of each other in terms of dollars per million BTUs. Starting toward the end of this graph, and let me blow it up here, this tracking diverged. And now the price of natural gas in terms of energy versus the price of petroleum has split. And as I'll tell you today, the feeling is that this is a long-term trend, that this split is here to stay for quite a long time. And this is one of the most significant changes in the energy, in the chemical world that we have seen. I can't overstate how significant this change is, particularly if it stays the way it is. And the thrust of my talk is going to be, what is the significance? Why is this significant? And what are some of the implications of this? But absolute, total game changer change. And let me give you a couple quotes. I'm not going to give too many in this talk, but a couple that are pretty recent. This is from a recent report that was just issued. And they say, it's called a revolution for a reason. In the span of less than 5 years, unconventional technologies for natural gas development have changed the outlook for U.S. national gas supply from scarcity to abundance, from high cost to moderate cost, from import dependence to self-sufficiency. Absolutely total game changer. As of 2008, 2009, we were talking about importing natural gas. We were talking about oil dependence. We were, the chance of building chemical plants in the United States was impossible. Nobody would ever dream of building another chemical plant in the United States. One more quote, and this is from the American Chemical Council. I'm not going to read the whole thing, but in red, one of the most exciting domestic energy developments in the past 50 years. And through the end of March 2013, nearly 100 chemical industry investments valued at $71.7 billion have been announced. And again, 2008, 2009, you could talk to any CEO of any chemical company in the world, they would tell you there will never be a major chemical plant built in the United States. Now we've got going on $100 billion of announced investments in the United States. Just one more comment on this. I was at a big oil and chemical meeting, CERAWeek in Houston a couple weeks ago, and the European chemical CEOs basically got up and said, I could summarize it this way, we're somewhat doomed in Europe, and all of our investment is going to be in the United States. And I'd say a lot of countries would also say that. So that's the setup. Revolutionary change, biggest change in 50 years in the energy and chemical industry. What are the implications? And what are the reasons for it? Well, the main reason for it is the development of hydraulic fracturing or fracking, which is really the result of the convergence of a technology called fracking combined with horizontal drilling, the ability to access natural gas in shale seams that we never thought we were going to be able to do. Highly controversial, most of you have heard about it, but it's really this convergence of horizontal drilling and hydraulic fracking, where what we can do is pump high pressure fluids down these drills and crack the shale seams and then prop them open with sand or other types of proppants and then remove the water and let this gas that we never thought we could access seep out and make it available. We can get into this in a little more detail later. And it turns out that there are abundant seams in the United States where we can do this. This is a map of the North American shale plays, the ones that we hear about a lot. The big one is Marcellus in the Pennsylvania area. There are a number of them in Texas, the Eagle Ford, the Barnett, and of course we all have heard of the Bakken, which is in North Dakota. These are terms that most of us didn't know about a few years ago. Now they've become sort of common vocabulary. Let me go back for a second and give a quick just vocab description here, since this is a general audience, on what I'm talking about. So first of all, methane is a one-carbon molecule. It's the most reduced form of carbon. Very simple molecule. There's the structure. Natural gas is a mixture of methane and a number of other minor components. So I will probably end up using methane and natural gas somewhat interchangeably in this talk, but there is a difference. Natural gas still has some ethane, propane, and some other components in it, but it's primarily methane, okay? And then natural gas can exist in a dry form, which really means it's primarily methane, or a wet form, which means it's got lots of those other components in it. But again, for the sake of this talk, natural gas is methane. And then finally, some units. And I don't think it'll be a big deal, but it's useful to know that 1,000 cubic feet of methane is roughly equivalent to 1 million BTUs. And so the units that are used, one is in terms of volume, one is in terms of the energy you can get out of it, but it's convenient that they're roughly the same. And so again, some of these graphs and things interchangeably, 1,000 cubic feet, million BTUs, roughly the same. So I just said biggest change in 50 years, revolutionary. What are some of the downsides? I want to just point out, it's not all, if it sounds too good to be true, it probably is. There's probably going to be some downsides. We know that there's a lot of water that is required to do this fracking. A lot of water has to be transported around, and there are some concerns about treating that water in polluted water. So certainly important. The National Geographic's just this month had an article called Green Fracking that described a lot of the technologies that are being used to deal with this. And there's even companies that have started at the University of Minnesota that are focusing on this. I'm convinced that the technology and solutions will be developed for this, but it is important. Traffic and other disruptions, fume and noise. So at least initially, when a frac happens, there's a lot of activity there. So these are trucks and things, pumping trucks, water trucks. This is what it looks like when a frac is initially done. You've got to pump this high pressure water down there. You got to get the water there. It's a lot of commotion. This is not the standard state. I mean, once the frac has been done, all these trucks go away and go to a new site to start doing it somewhere else. They may have to come back at some point to do a refrac, but it's a temporary event. But if you happen to live next to this place, you know, or it's your next door neighbor that's having a frac done, it can be very disrupting. So clearly, we need to think about that as well. You've all heard about earthquakes. There are some tremors and things in the soil, particularly in water disposal wells. Getting rid of the excess water that you've had to use is where most of them occurred. But in some fracking situations, you're putting a lot of pressure down there. You can have very minor earthquakes. Again, I don't think it's a big deal, but it's something that we need to look about. We've all heard of the flaring of stranded gas. So in some cases, methane is not the main product that people are looking for, but they're looking for the petroleum, but they end up getting methane. So you saw there's that price differential. The methane is abundant, but it's less expensive than petroleum. There are some cases where they're going for the petroleum, they don't have a way to capture the methane, and so we flare this, and so that can lead to some pollution. It's better to burn it, as I'll tell you later, than it is to not burn it, because looking down below, methane is a much more potent greenhouse gas than carbon dioxide. So you'd rather burn it than just let it go into the atmosphere. On the other hand, it's a little disconcerting to be wasting all of that energy. And then methane leakage, both through the fracking operation, but through all the transportation of methane. And since it is a potent greenhouse gas, we do want to track the methane leakage. So here's a graph that, or a picture that I've been told most speakers in this seminar series seem to show at least once. It shows Minneapolis, it shows the Bakken, and this is all of that flared natural gas. And again, it's being flared because there's no infrastructure to get that particular Bakken gas somewhere. And because of the low price, they're focusing on the more valuable petroleum. This is something that I think can be solved, but it is a little disconcerting. By the way, there are natural sources of methane that seep out of the ground. So it's not like methane, you know, never happens to come out of the ground naturally by itself. All over the world, there are natural sources of methane seepage. This is a park in New York, which is called the Eternal Flames Falls. You can go there, and there's methane that seeps naturally out of the ground, and it's burning. I mentioned methane leakage. Here's one of a spectacular example of this. This is San Bruno, California, the pipeline that blew up. So transporting methane is not without its hazards. It's something that most of us have learned to live with. We have methane in our homes, but we do have to consider it. So there are some of the downsides of this, but let me focus on some of the upsides as well. First of all, we should be happy. Methane is non-toxic and biodegradable. So now we have this compound that basically it burns, and if we're not careful, it can explode, but it's a pretty benign natural molecule. Probably the biggest upside is the displacement of coal for electric power, which has led to reductions in CO2 formation. So great reductions in greenhouse gases, reduction in sulfur, mercury, other pollutants in the atmosphere. And let me just show you this one graph. This is a projection of the coal versus natural gas for electric power production. So as you see, natural gas use is up, coal use is sort of down to flat, and it's predicted in 2035 or so we're going to be using more natural gas for electric power than we do for coal. And this is good because we generate approximately the half amount of CO2 per million BTUs or per unit of energy if we burn natural gas versus coal for electric power. So we have met all of our greenhouse gas reduction mandates up to this point simply by switching from less coal and more natural gas. Now, we can't meet all of our CO2 reductions going on into the future by this way, but up to now, we have had significant impact on CO2 production simply because of this switch. A couple other upsides. As I already mentioned, the revival of the U.S. chemical industry. And this means jobs, this means exports, so it's good for the U.S. economy. And 2009, no new major plants built in the United States. Nobody would have dreamed of it. Today, 2014, over $100 billion of investments. The biggest challenge is going to be, do we have people who know how to build these things and operators to run them? Not a bad situation to be in. Lower cost of energy for our households. This benefits all of us that use natural gas for our water heaters and for heaters. It's good news for us here in Minnesota. Cleaner and lower cost transportation energy. This is great for cleaning up and reducing CO2 via transportation. Let me just show you. This is probably the most techie slide in the talk, and I'm not going to spend a lot of time on it, but this is a phase diagram for natural gas. Pressure is on the y-axis, temperature is on the x-axis, and this shows that where it says STP, that's standard temperature and pressure, that's kind of what we're in now. Natural gas is a gas, but if we cool it, we can get a liquid or a solid, or if we change the pressure, we can change it into that region of a liquid and a solid. And I did this more for my own information as well. Compressed natural gas is, we pressurize it, but it's roughly at the same temperature that we are here. So we can keep a tank in our car. It's just pressurized, but it's not at a low temperature. Or we can make liquefied natural gas, and it's roughly at the same pressure, but at a much lower temperature. So these are the two sort of main transportation fuel forms of natural gas. And the LNG takes up less space because it's a liquid, it's more dense, but you got to keep it cool. There's one other form, by the way, it's called ANG, adsorbed natural gas. Huge amount of research on this. And this would be a way to basically take that compressed natural gas and draw that line down so that we can now have it stored at atmospheric pressure. So it's absorbing it onto some sort of surface. And there's a lot of research going on that. So the upper left is a CNG gas station. These are popping up. These are primarily good for automobiles or for shorter haul systems. Lots of taxis and things use it. The bottom one is LNG and long haul trucking. And if you go along the interstate, these LNG plants are going to be put in primarily for long haul trucks. Significant impact on the environment and a significant positive impact on pollution and CO2 production. One more upside, and this I say a little bit tongue-in-cheek, because one of the downsides that I didn't put on my list is this low-cost natural gas has really impacted investment in wind and solar and in biofuels. I do clean tech investing, and it is tough to compete with such low-cost natural gas. It has had a big negative impact on wind companies, solar companies, biofuels companies. So I'm saying this more tongue-in-cheek because I just don't particularly like the thought of a future of windmills everywhere I look. I'm just worried 30 years from now when we got all of these kind of defunct, broken down, poorly maintained windmills, it really is not the greatest thing to have in the rural environment. And solar panels. I just don't think that they're that attractive to have field after field of solar panels. So I think there's some downsides, but I think there's also some upsides. I think that our rural environments maybe will benefit from not being filled with windmills and solar panels. I need to make a few controversial comments in this talk. So, all right, a couple questions and concerns. because there are a bunch of them. One of them is, do we have enough methane, and will it maintain these low prices, or is this a flash in the pan? This is a graph that shows our estimates of how much recoverable methane we have in the United States going from 2000, and the latest estimate is 2013. And we continue to get more and more bullish about this, and the numbers get bigger and bigger as we learn more about what's going on. So this report that just came out said at current usage, 88 to 154 years of supply. So that's pretty good. The concept of peak oil is dead. Okay, we used to hear about it all the time. We've got enough methane, and I'll even make another point later, that I don't think we have to worry about running out of this stuff anytime soon. And then this is a cost curve, and I'm not going to spend a lot of time talking about it, but it's basically dollars per methane versus available in trillion cubic feet. And it shows how much is available at a certain production cost. And if you look at this graph, there's roughly 1,200 trillion cubic feet that is available at less than $6 1,000 cubic feet. Pretty cheap. And then, of course, you know, there's even more if we're prepared to pay more. The feeling is that this is going to be at a low cost for the long term, and as technology develops, some of those higher peaks are probably going to drop down. Now there's a bunch of political concerns. I want to just briefly touch on them. Should we export it? We got this huge abundance. It's caused a revival in the chemical industry. Should we export it? And this has become a political tool. One of the first things that happened when Ukraine got invaded by Russia was, well, let's just export natural gas to Ukraine and really put the heat on Russia. So there are ways to export it. It typically will add more than double the cost. So we can export to places like Japan and Europe. It'll cost at least twice as much as it costs here. It's still a bargain for them. So I think there will be a significant amount of exporting, and I still think we'll have low-cost methane in the United States, but that's a good point of discussion. Is this just a U.S. opportunity, or could this become a global opportunity? Here are the sources of shale in the world. I think the point is, yes, it could be a global opportunity. The U.S. is well positioned to do this technology, but other parts in the world will start to figure out how to do it. So it can become global. Methane generates less CO2 than coal, but it's not CO2 neutral. So it's been great to switch to methane for electric, but it's not CO2 negative or neutral. So are there ways to address that? And I think there are some. And then another concern is that, well, we've caused coal prices to plummet in the United States. We're not burning coal, but the coal guys are going to do something with it. It's being shipped to Europe and China. And so maybe in the global scheme of things, have we solved the problem or not? And clearly that's a consideration that we need to think about. Coal is being transported around the world. It's not going away. Some big questions to think about. So switching then to the final part of my prepared comments before questions, moving forward, directions and opportunities for the future. So to reiterate, we have abundant global supplies of shale gas, natural gas. In the future, and this is where I'm bullish, and this is why this concept of peak oil or peak natural gas, I think, is not going to be an issue anymore. We have even vaster sources of natural gas. So this is a graph that sort of shows a pyramid of the supply. We're looking at what's called shale gas, but there's also coal bed methane that's not being exploited right now. And then there is just absolute vast supplies of things called methane hydrates. So methane that's complexed with water in the oceans that Japan and other countries are looking at. And the supplies of these hydrates vastly dwarfs the amount of even shale methane. And these are sources of this. And so over time, I think people will start to learn how to get this and how to exploit it. The costs will go down. Here's an important positive. We've got a vast distribution network for methane in the United States. Most of you get it in your homes. One of the challenges of other green, clean things, say hydrogen, is there's no network to distribute this. You know, none of us get hydrogen to the gas station or hydrogen to our houses. We've got this vast network that we should tap into, take advantage of, and it continue to grow and continue to get better and, you know, more robust over time. So that's, I think, a positive of this whole methane boom. Then another one that I'm excited about is that there are renewable sources of methane. It's called biogas. They're available now, and there is tremendous potential over time to make this even better and more robust. So what we can do is we could transition from fossil methane over time to renewable sources of methane. This is just one picture. There's a company called Redox Power that takes various wastes, yard waste, composting waste, scraps and various things, and converts it into biogas. And a plus is that we also get rid of some of our wastes. And another plus is some of those wastes have fertilizer value and other uses. So there is a truly green, clean situation here as well that is less competitive now because the gas costs more, but it has other environmental benefits, and over time we may be able to transition to more of a renewable form of natural gas. And this is just a map that shows existing biogas facilities that are already present in the United States. So we've already got a foothold, and I think these can even get better and better. And then finally, I think abundant low-cost methane provides a strong economic incentive to develop new technologies, new ideas, and new processes. So people complain that venture capitalists don't invest in, you know, all these new kind of green, clean technologies and things. And maybe they don't as much as we would like, or oil companies don't invest in them. I guarantee you they are investing in looking at methane. The backers of our firm are very interested in it. We spend a huge amount of time looking for new technologies, and if we see good new technologies related to methane, companies will invest in them because you see this huge abundance, this low cost, this long-term opportunity. It is just stimulating incredible innovation throughout the world. So I just threw a couple examples. So Bloom Energy is a company that's made fuel cells that can take methane and convert it into electricity directly. It's a fuel cell. And these are being used by places, and this one here is eBay, but Google, all sorts of companies are installing these methane fuel cells for backup electric power. There are a bunch of companies that are now making these for the home. This is just one called Redox Power. You can get one of these boxes and, in theory, stick it in your basement. And now what you can do is have either electric power that is based on methane as opposed to power from the power company. It could be a backup source of power in case the grid goes down. Or, since we have such an extensive pipeline of methane, in theory, somebody could decide to go completely off the electric grid and just power their entire house off of the methane. You know, not even bother to buy electricity anymore, just buy natural gas. One of the potentials that might happen. And then, close to the final slide here, I'm a former chemical engineer. I like chemistry. There will be just a revitalization of chemistry related to methane. It's tough to do, but we now have the incentive, in the long-term incentive, to put a lot of resources and a lot of effort into it. So we can convert methane into synthesis gas, which is carbon monoxide and hydrogen. And this is a building block of the chemical industry already. We've made an investment in a company that converts methane into carbon black, the material that makes tires black. Oxidative coupling of methane, a venture-backed company that converts methane to ethane. Partial oxidation of methane to methanol is one of the holy grails of chemistry, and there is a huge incentive to do this these days, and lots of money going into that. There are other companies that are taking methane and going directly to other chemical building blocks like benzene, which is an important aromatic building block. So huge amount of innovation. ARPA-E is funding biotech-based uses of methane. I'm not going to say anything about this, but just say that if you're a professor in the biosciences, I'm sure you know about this. Lots of money available to do bio-based conversions of methane. And we've got some Cargill people in the audience. Very interesting, Cargill makes biodegradable plastics out of sugars, and they couldn't ignore the methane boom either. And so they have a research project where they've teamed up with a company to look at, can we make these biodegradable plastics out of methane as opposed to sugar and starch? So the point is, huge amount of innovation going on in this area. So this is my final slide. Professor Foley said, leave a big idea, food for thought. Abundant methane is a unique and unexpected opportunity. Biggest change in over 50 years. Rather than reluctantly accept methane as a bridge or a transition fuel, which a number of environmental groups say is okay, it's a bridge fuel, but eventually we're going to move to something else. Let's embrace it, innovate it, and use it to develop a cleaner and more prosperous future for the United States and the world. Why does it have to be a bridge fuel? It's abundant, the infrastructure is there, there are bio-based sources of it, it can have environmental benefits, and it's probably never going to go away. We're going to have plenty to keep us going for hundreds of years. Let's not reluctantly accept it, let's embrace it and see if we can make it work better. And with that, I will close and would love to have some discussion and questions.